All right, let's get started. I am starting with the January 2017 Regents. So make a note of that for yourself. You can get this by just Googling Common Core Algebra 2 Regents, and they all show up. I'm just going to go through the questions that I've taught you guys. That I'm not going to go into other topics and try to teach them on the spot. I just want you guys to see the ones on the Regents that you've learned up to this point. So right away, to start us off, we can do this problem. You've learned this. Let me prove to you. So it says relative to the graph y equals 3 sine x, what is the shift of the graph? You see that? You can do it. Y equals 3 sine x plus pi over 3. Well, this is the parent function. And this is the augmented function, or the shifted function. And this thing is shifted to the left pi over 3 units, because that's in the parentheses. Let's just test the poll. Okay, good start. Let's keep going. Okay, so we're going to skip over 2. That has nothing to do with what we've learned. Let's see, number 3, factoring completely. We can do that. So first thing that we do when we factor is we always see if there's a GCF, right? This situation would be potentially a trinomial, except this is a 5, not a 2. So we're not going to do that. So we're going to factor out the GCF of m. This is going to be m times, hold on one second. Guys, just please make sure you mute yourselves when you come in. Okay, so we've got an m here, which I factored out. Now we are left with m to the 4th plus m squared minus 6. And it looks like we can probably trinomial factor now this. So we leave the m out here. And you write an m squared, so you just half whatever's there, plus m squared, plus times the plus is a minus. And let's see, a 3 and a 2. And this is it. Because m squared times m squared is m to the 4th. This will be 3m squared minus 2m squared gives us 1m squared, and 3 times negative 2 is negative 6. So our answer is 4. Okay, number 4, we didn't do anything with that. System of equations, number 5, we can do this. What is a system of equations? What is the solution when this and this are, okay, so g of x, this, and they want to know this. So we've got a y-intercept of negative 2. You can do it right on the graph. And a slope of 3. So you go up 1, 2, 3 over 1. 1, 2, 3 over 1, right? So right away, we see one of the solutions is the point 1, 1. Let's see if that helps us. This isn't it. That's not it. That's not it. This is the only one that has 1, 1 in it. So this is our answer. And I guarantee you if I kept going, I would get to 6, 16. But it's kind of off of the graph. It'd be like up there a little bit. Okay, next one. I promised you guys this would be on every single one. Which statement about statistical analysis is false? Let's see. Experiments can suggest patterns in data and relationships in data. That's true. All right, true. Experiments can determine cause and effect. That's true. Observational studies can determine cause and effects. That's false. And observational studies can suggest patterns. That's true. So they want the one that's false. That is number 3. Okay, 7 we can do. They're asking what is equivalent. Let's see, so we do the subtraction first. So we do m to the 2 minus 1/3, and all that to the negative 1/2. Let's see, 2 minus 1/3. 2 over 1 minus 1 over 3. Let's give these same denominators. This will be times 3 over 3. So we get 6 over 3 minus 1 over 3, 5/3. So this becomes m to the 5/3 to the negative 1/2. Remember, EMA, exponentiation distributes through multiplication, or a power raised to a power you just multiply. So this is m to the 5/3 times negative 1/2, which gives us m to the negative 5 over 6. When we have a negative exponent, we can flip it. So this becomes m to the positive 1 over m to the positive 5/6. And let's see, we rewrite this in radical form, and it's 1 over the, remember the denominator is the radicand, 6th root of m to the 5th. Answer is choice 2. If you have any questions about this stuff, just wait till the end of the webinar. Write down January Regents number 7, for example, if you want me to go back and discuss that one. But from now, I'm just going to move on. Inverse, we've never seen this function. It happens to be answer choice 3, but we're going to do that right when we get back from break. We haven't done this. It looks like we can probably do number 10. So this equals that, that equals that. They want us to multiply them. So they want us to multiply AB to the X times CD to the X, and just multiplying things. So this just becomes A, B to the X, C, D to the X. Let's see, I can use the commutative property to move things around. So this becomes A, C, B to the X, D to the X. This becomes AC, and I could put BD to the X out there if I want. And it's answer choice number 3. All right, this is actually a case of EMA as well. We just did it in reverse. So that's another one that we could do just with what we've learned so far. Here, quadratic formula. Okay, they give it to you in the back. So let's see, A is equal to 18, B, negative 24, C, 87. So we do negative B, which is 24, x equals, plus or minus the square root of B squared. So 24 squared is 576. minus 4 times 18 times 87. So 576, I'm just using my calculator now off screen, minus 4 times 18 times 87 equals negative 5688. The whole thing over 2 times a, or 36. So negative 5688, 24 plus or minus over 36. Let's look at some of these answer choices. You got a 6 and a 158. 5688 divided by 6. No. Let's see. So I'm just looking at the answer choices. I'm seeing this 158. So I just divided this by 158 and I got 36. So that's the perfect square that goes into this. So this is 24 plus or minus the square root of negative 36 square root of 158 over 36 over 36. Let's see, 24 over 36. We can simplify that into 4, 6. We can simplify that further. 12, 24. So this is 2/3 plus or minus 6i radical 158 over 36. 2/3 plus or minus I radical 158 over 6. 2/3 plus or minus. So the answer is answer choice 4 for that one. Okay, so just a lot of stuff. It's a quadratic formula. Don't get that one wrong. No reason to get that one wrong. But the little trick that I did there was I noticed that this 158 was in all of them, so I divided that into my radicand. Okay, 12. Easiest one. Hope you guys see something like this. When g of x equals this, h of x equals this, are graphed on the same set of axes. Which coordinate best approximates their point of intersection? Let me this. Okay, so I'm just going to plug these into the calculator and then use the intersect button. 2 divided by x plus 2 and log x plus 1 plus 3. Log, let's see, x plus 1 plus 3. And the plus 3 on the outside. So it shifted to the left 1 and up 3, whatever this function is. All right, it looks like the intersection's right there. I'm going to zoom in a little. See if I can't get a better picture. Okay, that's pretty clear. Second, trace, 5. Enter, enter. Over and guess. Enter. Answer is negative 0.9 and 1.8. Negative 0.9 and 1.8. Negative 0.9 and 1.8. Answer choice 1. Okay, let's move on. I do think that you could use a calculator just to figure this one out, and I'll show you quickly why. basically what you would do in this is just look at this chart, right? It's going like this, you know. And if you punch in this into the calculator, it's not going to look like that. It's going to look like a straight line. If you punch in this to the calculator, it's going to look like this wavy thing. So it's that you'll know that's not it. So it's going to be between this one and this one. And you'll notice that this one rises up a little too aggressively. It's like it looks kind of like this. But the other one seems more appropriate. So just by looking at them in the calculator, you could get this one correct without any prior knowledge. Not going to do this. Not going to do this. Not going to do this. This one we can definitely do. Okay. We have to make all of the denominators look the same. So let's see. 4 minus x. Let me factor this thing first. Not a lot of space for computations here, but 2 over x plus 3. I'm going to leave some space. Minus 3 over 4 minus x. Leave some space. Equals 2x minus 2 over let's see, minus plus 4 and 3. So let's see, x minus 4. X minus 4 is different than 4 minus x. So we kind of have to figure this one out. Let's take a look at 4 minus x. If I factor out a negative 1 from here, this is negative x minus 4. So notice how these two things are the same. So if you ever want to switch the order, you just change the signs and you can factor out a minus, which means I'm going to write this as a negative on the outside, and instead of 4 minus x, I'm going to write it as x minus 4. And now that I have a negative and a negative, these make a positive. So that means this goes away and those make a positive. So now I have my tricky one. That means I have to multiply this by x minus 4 over x minus 4, this by x plus 3 over x plus 3, and now I can cancel out all the denominators. Let's see, so we distribute, this becomes 2x minus 8 plus 3x plus 9 equals 2x minus 2. Let's see, so the 2x, subtract 2x from both sides and they cancel. Let's see, add 8 to both sides and you'll get 3x plus 9 equals 6. Subtract 9 from both sides and you'll get 3x equals negative 3. Divide by 3, x equals negative 1. So the key to remember with that is if you have a minus b, that's equal to negative b minus a. Okay, 18, we're not doing that. 19 we can do. We just have to graph each of these functions and then look at their maximums and their minimums and stuff like that. I don't really feel like doing it right now just because it's going to take me too long to graph it on the calculator. I don't even remember which one is the answer. I'll tell you though now. Well, it doesn't really matter. The bottom line is just graph each of these things and then look. I know this has a maximum of 3. I think this has a maximum of 3. So those are true. Basically just use the calculator. But again, it just takes too much time for me. Okay, let's reason out number 20. When g of x is divided by x plus 4, the remainder of 0, so that means that x plus 4 is a factor. And it also means that f of negative 4 would equal 0. So let's look. Given this is g of x, which conclusion can be g of 4 isn't 0. G of negative 4 is equal to 0. X minus 4 is a factor. No, x plus 4 is a factor. And no, we can make a conclusion. Our conclusion is 2. This is the remainder theorem. Okay, Joella has a credit card, compounded monthly. She owes a balance. Maybe we can do this, assuming she makes no payments. Over which interval of time is her average rate of change for the balance on her credit card the greatest? So this is an average rate of change. So month 10 to month 60. So you would calculate the average rate of change of those, of each of these intervals. I'll do the first one. So you would do 25, 91. Sorry. Remember, it's right, y2 minus y1, x2 over x1. So this is our y2, this is y1, this is x1, this is x2. So you would do 25, 91, spot 90 minus 1172 over 60 minus 10. And whatever that is your average rate of change. And then just note that next to here. And then calculate the second one, calculate the third, and the fourth, and then just pick whichever one's the larger one. We don't know how to do this one, number 22. We don't know how to do 23 yet. Let's take a look at 24. I do believe we can do that. So over which interval is the volume of the box changing with the fastest average rate of change? Well, that just means that which has the largest slope. So from 1 to 2, here's the slope there. From 1 to 5, let me make this green. From 1 to 5, the slope is 0. So it's not 1, 5. From 1 to 3.5, the slope is less than the first one. And from 0 to 3.5, that slope is also less than the blue one. So the answer to this is answer choice 1. This has the fastest average rate of change because I'll do it in this purple. From here to here, this is a steeper slope than all of the others. Okay, express 1 minus I to the third in a plus bi form. One minus I all to the third. 1 minus second decimal I all raised to the third equals -2 minus 2I. That's the answer. That's it. Okay, 26. This one's really, you can reason this one out. An orange juice processing plant receives a truckload of oranges. The quality control team randomly chooses 3 pails of oranges, each containing 50 oranges, from the truckload. Identify the sample and population in the given scenario. Well, the sample is the pails of oranges. It's like if you surveyed people, we talked about surveying like one lunch period versus the others. The sample would be like first period. And the population is always everything. Population is the truckload of oranges. Okay. State one conclusion that the quality control team could make about the population, so the truckload, if 5% of the buckets were unsatisfactory. Well, if 5% of the sample is unsatisfactory, you can make the state a conclusion that 5% of entire population is unsatisfactory. And that's just statistics, which we'll get into. Not going to do that. Determine if the function represents growth or decay. You could graph this, and you'll see that the graph goes down. And if you kind of know what the word decay means the opposite of growth, basically. A growth graph is going to look like that. So you could say, you know, when graphed, the slope is negative or function is decreasing, so it represents decay. I know we didn't do that yet, but this is one that you can reason. On the grid, sketch a cubic polynomial with these zeros. I believe we did this in class. So you sketch. Zeros are 1, 2, 3, and -2. So I'm going to come up like this, down, put arrows. That's the answer. And yes, if you started from the top, it would have just looked like this. Because it doesn't say anything about the leading coefficient. Okay, given the equal terms, determine and state y in terms of x. That just means solve for y. So we set these equal to each other. Cubed root of x to the 5th equals y to the 5/6. I'll convert this. X to the 5/3 equals y to the 5/6. We want to get y alone, right? State y in terms of x. So watch what I do here. I'm going to raise this to the 6/5 power on both sides. Why? Well, that will give me x to the 30 over 15 power on the left equals y to the y to the 30 over 30th power here. So I get x squared equals, that turns into a 1, y. Or y equals x squared, same thing. We're not going to do anything with this. Okay, this one, polynomial long division. Polynomial. That's it, I'm not doing it. You guys can do that. Okay, the part 3s. Not doing this one. Let's see, nope. We haven't done anything with arithmetic or recursive. This is probability. We haven't done anything like that yet. This, haven't done anything like this either. You can kind of reason this one out though. And let's see, we have done this. This is a radical equation. They're saying the speed of a tidal wave s in hundreds of miles per hour can be modeled by this equation, where t represents the time from its origin in hours. Algebraically determine the time when s equals 0. So 0 we replace for s equals radical t minus 2t plus 6. What do we do with radical equations? We get the radical thing to one side. So we'll add 2t to both sides and subtract 6. So this becomes 2t minus 6 equals square root of t. We square both sides and we get, let's see, 2t times 2t is 4t squared. Negative 6 times 2t is negative 12t. And another negative 12t is minus 24t. Negative 6 times negative 6 is positive 36 equals t. We'll subtract t, because now we have a quadratic, and we set it equal to 0, minus t. And we get 4t squared minus 25t plus 36 equals 0. We factor, but there's no GCF, so we're going to use the AC method. So you do the 4 times 36, gives you 144. I'm going to continue this problem up here. So this becomes now t squared minus 25t plus 144 equals 0. Second step in the AC method is you factor the trinomial. Minus. I'm going into my calculator. I'm going to press, I'll show you guys what I'm going to do. y equals 144. Oops, let me clear all this. I'm going to do 144 divided by x, and then I'm going to go to second graph, and this shows me all of the factors. So I need 2 that add to 25. So 24 and 6, for example, are multiply to 144. 18 and 8 multiply to 144, but they add to 26. 16 and 9 multiply to 144, and they add to 25. So we want 16 and we want 9. So that would be t minus 16, t minus 9. And remember, when we did the AC method, we had a 4 out front, so we have to attempt to divide both of these by 4. It works over here, so this becomes t minus 4. Doesn't work here. And 4t minus 9 equals 0. So t equals 4, or let's see, 4t equals 9, t equals 9 over 4. Now you have to check results for extraneous roots. Because it's a radical. It turns out that you reject this one. So t equals 4. For, 4 seconds, right? Or 4 hours, 4 hours. Okay, how much faster was the tidal wave traveling after 1 hour than 3 hours to the nearest mile per hour? Justify your answer. That means show work. So we have to substitute this in. So s equals the square root of 1 minus 2 times 1 plus 6. So this is 1 minus 2 plus 6. So 1 plus 4. So s equals 500 miles per hour after 1 hour. And let's see, after 3 hours, s equals square root of 3 minus 2 times 3 plus 6. So this is radical 3 minus 6 plus 6. So radical 3, using my calculator, square root of 3 is about 1.732. Remember, this is in hundreds of miles an hour, so about 173 miles per hour after 3 seconds. So the difference is 500 minus 173, and 500 minus 173 is 327 miles per hour. All right, for this question, this poll that's going to come up is for this entire Regents exam. So how well do you feel that you understood this entire Regents exam? Okay, nobody said no. Let's move on. We'll do January 2018. Okay, we're doing now January 2018, so we've jumped a year. And question one, the operator of the local mall wants to find out how many of the mall's employees make purchases in the food court when they are working. She hopes to use these data to increase the rent and attract new food vendors. In total, there are 1,023 employees who work at the mall. The best method to obtain a random sample of the employees would be to survey one, all 170 employees at each of the larger stores. Two, 50% of the 90 employees in the food court. Three, every employee. Or four, every 30th employee entering each mall entrance for 1 week. Well, all 170 employees at each of the larger stores, but what about the smaller stores? That's kind of biasing. 50% of the 90 employees of the food court. Well, they want to see how many of the mall's employees make purchases in the food court. So that's really biased. Every employee, that's not really a sample. That's a census. Every 30th employee entering each mall entrance for 1 week, that would give you a pretty random sample. So the answer is choice 4. Yeah, that would be the least biased, I would say. Okay, 2, what is the solution set for this equation? This is a radical function, and we're given the answer, so we don't have to square anything like the tidal wave or whatever. We just have to check the answers. So let's see, let's check. We have to check -1. We have to check 0. And we have to check 1. I know we did this one in class, but I'll make it quick. So -1 plus 1 minus 1, does that equal -1? Yep, -1 equals -1. So -1 is good. Oops, it's +1. -1 is good. -1 is only in 3. It has to be answer choice 3. Let's just check 0 though. 0 plus 1 minus 1 equals 0. This is the square root of 1 minus 1. Does that equal 0? 1 minus 1 equals 0. So just test taking tricks. It's got to be number 3 because -1 worked. -1 is only in answer choice 3. Okay, 3, for the systems shown below, what is the value of z? Again, I feel like we just did this, but let's sub 1. Let's sub 1 into 3, so we get 3x minus -2x plus 14 equals 16. 3x plus 4x minus 14 equals 16. Add 14 to both sides. 3x plus 4x is 7x. This isn't right. What did I do? If someone wants to tell me in the chat what I did wrong, let me know. I feel like I screwed something up. Yeah, you could find the special equation, but it's easier if you just substitute it in just for this specific one. Because I don't know, I know like we did this in one in class just the other day. So we get 3x minus negative 2x plus 14 equals 16. 3x plus, I added incorrectly. This is 5x equals 30. X equals 6. So you see over here, if you just do this, you get x equals 6 pretty quickly. But now you just sub that in to equation number 2. So you get 3 times 6 minus 4z equals 2. 18 minus 4z equals 2. Minus 4z equals negative 16. Z equals 4. Now, yes, you could have done it this way. You could have rewritten equation 1. And let's see. This could have been 2x plus y equals 14. This would be 3x minus 4z equals 2. I'm lining them up. And this is 3x minus y equals 16. In this situation, I would say that there really is no special equation, but I would do 1 plus 3, and that'll get you 5x equals 30. X equals 6, just like before. And now you sub x equals 6 into 2. This one's like simpler than the other ones that we've done. And because it's simpler, we don't have to follow the same steps. And because we don't have to follow the same steps, it seems more difficult. Okay, 4, the hours of daylight in Utica can be modeled using this equation. How many hours of daylight does this predict? We're not going to do that one, although you can figure it out. Certain pain reliever. You can figure this out if you reason it out, but we haven't done it. 6, this expression cannot be written as, let's see. Well, it can be written as x squared plus ax plus bx plus ab. So x squared Let's see, if I FOIL this, if I double distribute, this could be x times x plus b plus a times x plus b. Does that look like any of these? Try this. I'm going to factor out the x squared plus x times a plus b plus ab. So it can be written like this, because these are the same. Okay, can it be written like this? Ax plus bx, ax plus bx plus x squared plus bx. I'm sorry, ax plus ba. Yeah, this and this are the same, so it's not this one. Let's distribute all of this. You get x squared plus ax plus bx plus ba. This and this are also the same. So this is the one it can't be written as. The answer is choice 2. What I did in that is I just expanded all of these. I expanded this. I multiplied the a and the x. I distributed here. This I actually, yeah, I expanded. If you multiply the x times here, if you just expand all of these things, you'll see that this is the only one that doesn't make sense. Okay, 7, not going to do that. 8, I'm not going to do that. 9, easy. Remainder theorem. I'm sorry, long division. Easy. Yay, you should get that. Okay, 10. Compounded, we haven't even touched on this. 11, we've done this problem so many times. You just do the square root of a to the 5th over a, which is a to the 5 over 2, over a to the 2 over 2, 5 a to the 3 over 2, which is the square root of a to the 3rd. We've done that in class. It was on tests. We've done it so many times. That's why I'm rushing past it. Solutions to this: quadratic formula. Not going to do it. It's just the quadratic formula. It's actually the quadratic formula after you do the cross out denominators. So cross out, then quadratic formula. And we did this. You guys have that in your packets along with the answer. So if I rush by anything, I'm just trying to be efficient with our time. Not going to do this. 14. You should hope that you see something like this. You just use the calculator and find their intersection. I'll do it. New share. Okay. That was the absolute value. So you go to math, number, ABS, and it was x squared minus 9. And there was a minus 3. And the other equation was log base 3 of x. So you go to math, log base 3 down there. And in x, you just make it look like it did. Looks like we need to view a little more on the right. That's a cool graph. So we need two answers. Second trace 5. Enter, enter. One of our answers is 2.29. And 3.63. 2.29, 3.63. There we go. Answer choice 1. Okay, 15. Haven't done. 16. Equation for the directrix of the parabola. Let's see. So this thing opens down. You've got 4p equals -8. So p equals -2. The vertex is at -4, +3. So I'll draw this thing. -1, 2, 3, 4, +1, 2, 3. This is the vertex. It opens down. And the p-value is 2. So go up another 2. So this was 4. So this was 6. Sorry, this was 3, which means this is 5. So y equals 5 is the equation for the directrix. Okay, 17. This function models the average price of gas in a small town. If g of x is the average price of gas in dollars, the absolute maximum. So you want to use your calculator for this to find the maximum. So it was negative 0.0049 x to the fourth, or t to the fourth, plus 0.0923 x to the third minus 0.56 x squared plus 1.166 x plus 3.23. And it says on the domain 0 to 10. So 0 to 10, let's graph it. We want to find the highest point. We don't need the y min, we could make 0 instead of -10. So it's either this little bump or that little bump. I'm going to make the window, the y max, a little less, maybe like 6. Okay, it looks like it's this one on the left. So we'll do second calc maximum, and you go to the left of the max, and then hit enter. So I'm to the left of it, enter. Go to the right of the max, hit enter, and then you go somewhere in between. And the y value is what we're looking for, because we're looking for the height. So it's 4. So 4.007, so 4.01 we can round it to. 4.01, and that is answer choice 3. '18 written in simplest form. Let's see, I got a dots situation on the top, so I'm going to write that as C plus D, C minus D. Simplest form, this always means that you factor and cancel. So factor, right, I sent that Word doc out that shows you all the tricks. Let's see what we do here. D squared plus CD minus 2C squared. D squared. I'm going to need a C in there. Plus 2C. So this should work. D plus 2C, just factoring the trinomial. D minus C. Remember what I mentioned earlier, if you want to switch things around, you can just pull out a negative. So we can rewrite this D minus C as C minus D. We just have to pull out a negative. So this can become C plus D, C minus D, over negative C minus D, and D plus 2C. Now we can cancel those, and we're left with C plus D over negative D plus 2C. Let's distribute this negative through. So we have negative C minus D over D plus 2C. That was tough, but the answer is 3. Okay, 19, easy. Remainder theorem. Very, 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 very easy. You just do f of 5, and I believe that comes out to 240. $20, not doing it. 21, inverse, swap the x's and y's. So you get x equals negative 6, y minus 2, x equals negative 6y plus 12, x minus 12 equals negative 6y. Divide both sides by negative 6. Y equals x over negative 6 plus 2. Change this to f inverse notation. Answer is choice 2. 22 not going to do. 23 not going to do. 24 not going to do. 25, we did this one in class. Right, this was the mistake right here. Not going to do that. It's probability. We did this one in class. You have it on your packets. Completely factor the following expression. Probably with 4 terms, so we're likely going to use grouping. We could factor out an x, and this can be an x plus 3y. And here we can't factor anything out, so we can rewrite this. Let's see, let's put the y's together. So this could be x squared plus 3x to the third plus y plus 3xy. We're allowed to change the order of these any way that we want. Here's the binomial factor, 1 plus 3x. And that's the answer. Not going to do 29. Okay, so this is an average rate of change one. Just know that. Average rate of change. Here we do the sketch. Right, the zeros are at -1, -2, +2, and 3. Make it a little neater than that, obviously, but that's how you do it. The explain thing, again, you have it written down. The denominator is the radicand. So 4th root of 81 is 3, and 3 to the third equals 27. Throw this somewhere. This, just multiply this times this, do the addition. Okay, this one's a good one. Write an equation for this. So what are the zeros? The zeros are -4, 0, and 2. So we can write an equation, f of x equals x plus 4, x plus 0, x minus 2. That's it. The function g is formed by translating f left 2 units. Write an equation for g of x. So g of x means that we're going to shift this whole function left by 2 units. Well, how do we shift something left? We add 2 on the inside. So this becomes x plus 4 plus 2, x plus 0 plus 2, x minus 2 plus 2. Plus 2. So we get x plus 6, x plus 2, and just x, or x plus 0. That is to say, this 0 would now go, well, that's supposed to be a 3, whatever. This 0 would go over there. All right, so this function is going to be shifted. You could graph this. You could use your calculator to graph this one, 37. The rest would be difficult. All I'm going to do now is I'm just going to take 2 more Regents exams. I'm not going to do any work. I'm just going to pull them up and just show you that all of the ones that you can do based solely on what I've taught you guys. So we did the January Regents. Let's do August 2017. Okay, and here we go. This one you can do. All you have to do is find out what is the x value that makes the denominator 0. Can't divide by 0. Okay, so you factor. Let's see. Number 2. So this you can do. Number 2, you can do imaginary unit. All you have to know is that I squared equals -1. Number 3, you can do it. Just factor or use the quadratic formula. So right off the bat, that's 3 right there. That's 6 points out of the 26 that you need to pass. Right, 3 off the bat. 4, what do? You just plug these in. Plug that in, see if it works. Plug this in for x, plug this in, plug these 2 in, see what works. Bam, that's another one. This one, we don't know how to do. Although you can probably put it in the calculator and figure it out, but I'll teach you guys that one in more detail. 6, focus directrix. Well, what do you know? We can do that, definitely. Let's see, 7, don't know how to do it. 8, set it equal to 0, and then factor. We can do this. This is a polynomial. So solve polynomial. So you set it equal to 0, right? You do the t-chart. We can do that. This one looks like, an average rate of change 1. No, it's not. We don't know how to do this. We don't know how to do this. And we don't know how to do this. Over here, we can do, this has to do with the zeros of a polynomial. 13, polynomial long division. 14, find the inverse. 15, you would factor, you'll probably work it out. 16, no. 17, yes. Observational study, a researcher gathers data versus this would be an experiment. So again, I'm not going to go into it, but this is, yes, you can do this. We don't know this yet. This you can do. 19, substitution. Remainder theorem. Just plug in -2, plug in -4, plug in 6, plug in 7. We don't know how to do 21. We don't know how to do 22. Yes, 23 we can definitely do. 24 we do not know how to do. 25, oh my gosh, explain. Yes, we can do that. 26, nope. 27, nope. 28, we didn't explicitly learn it, but you can reason that. 29, nope. 30, nope. 31, kind of. 32, yes, you can sketch this graph. 33, yep, cancel out the denominators. And this is a 4.1. 34, nope. 35, nope. 36, no. And 37, yeah, you could put in your calculator and use tables. That's all you could do. So you could definitely pass this exam with just what we know. Let's pull up another one. Let's do August 2017. See what that looks like. And then I'm going to end the session. Okay. Oh, we just did this. We did August. Let me do June and 2018. Okay, the June ones are normally harder. Let's see though. Okay. Yes, substitution. That's 1 that you can get. 2, no. 3, factor and cancel. That's 2 that you can get. 4, nope. 5, yes. That's 3 that you can get. Imaginary number. 6, yes. Graph these and look at which one is reflected over the y-axis. That's another one that you can get. 7, no. 8, definitely. 9, cancel the denominators. Or just plug these things in, actually. That would be easier. 10, no. 11, no. 12, yes. Plug in +1. 13, yes. Profit function. Just read it carefully. 14, no. 15, you can figure it out. 16, definitely. Just there's a 0 at -5, a 0 at 3. So -5, a 0 at 3, and I a -I, so it's got to be 2. Yep. 17, no. 18, no. 19, no. 20, definitely. 21, definitely focus directrix. 22, you could figure it out. 23, no. 24, no, but 25, no. 26, yes. You just graph this thing, put it in your calculator and actually graph it. 27, yes, quadratic formula. 28, this is how's my driving. We talked about this one. Some people might drive longer than other people. Some people might drive different routes, so it might be biased as to what feedback that they're getting. 29, polynomial long division. 30, no. 31, no, we didn't explicitly do it. 32, no. 33, yes. Just move the x to the other side, distribute, then square both sides, and then check your answers for extraneous roots. 34, no. And 35 and 36, no. And this one you can graph using a calculator. I looked at all of the Regents, guys, and here was the thing. In every single Regents that I've looked at, just knowing the stuff that we've done up to this point, you can get about a 77 to an 80 on every Regents that's happened in the past. So if you want to pass this thing, you can. All right, I'll take any questions right now, but I'm pretty exhausted and I kind of want to go, and I'm a little discouraged that I only have 6 people still with me right now of the 144 students that I have. So it shows me how serious everyone is to wanting to pass the Regents. But thank you everybody that hung in there. Just type in the chat box if you have any specific questions you want me to go over. All right, guys, we're done. I'll upload this to YouTube in case you missed anything. See you guys tomorrow if you're in school. Otherwise, I won't see you Thursday. Email me if you have any specific questions. Delta Math is going to be your savior on this, and just do whatever research you need to. There are other YouTube videos out there. Just if you want to pass this test, you can do it easily, really, really easily, if you just know the stuff that we did. Okay? Have a good night.